This is a Zenith T5F Carburetor and it's over 105 years old. After a century, it's showing its age, with the cast iron housing having a nasty crack and the venturi in a similar state of disrepair. We've been tasked with repairing the carburetor for the City of Greeley Museums so that they can get their 1920 Federal truck running again. From my understanding, it started its life as a school bus in Windsor, Colorado, before undergoing a restoration and ending up with the City of Greeley Museums. It's not every day that you get to work on something this uncommon, so we're excited to have the opportunity to help preserve some early automotive history that also happens to be pretty local to us. Stay tuned to watch us use a combination of some old tricks and some new technology to keep this history alive. We started out with stripping down the carburetor to the bare essentials, that way there's less chance of us breaking any more of those obsolete parts. We'll go slow and take our time because who knows when the last time any of these fasteners were loose, and I'm going to guess they're pretty corroded. We don't want to lose any of these parts either, so we'll keep close track of them and make sure that we remember how they go back together.
No.
Now that the carb is stripped down, we can set all of the extra pieces aside and get started on the repair. We're going to need to press the venturi out of the housing, but I have no idea how difficult that may be. So before we damage anything, we're going to get a good 3D scan of it as it sits. This is the new Creality Surmoon S1 3D scanner, which they sent me to try out, and I've used it on a couple of projects so far, and it's perfect for this application. The 34 cross blue laser line mode makes for quick scanning of the overall object, while the 7 parallel line mode can pick up the detailed surfaces, but the most valuable in this project is a single laser mode, ideal for accurately capturing the deep internal dimensions of the venturi in this carb. Using the Creality Scan 4 software, we can take two different scans, one upside up and one upside down, and after cutting the unneeded scan data, we can align the two scans to ultimately export a single mesh of the object. I've been impressed with the level of detail that the scanner picks up and the accuracy that I've been able to achieve with it, even with a very limited amount of prior 3D scanning experience. So at this point, we at least have a backup file if we do break something pressing the Venturi out and we have to reverse engineer the entire carb, but let's just hope that doesn't happen. It actually came out easier than I expected, and wasn't near as corroded as I thought it might be, so since the only scan data that we really need is of the Venturi itself, let's go ahead and scan the Venturi on its own, since we now have easier access to both sides. The S1 is accurate down to 0.02 millimeters plus 0.08 millimeter per meter volumetric accuracy, runs up to 90 frames per second, and it doesn't struggle with tricky materials or spray-free scanning of black or metal surfaces, which is perfect for old engine parts like this. If you're into reverse engineering, restoring vintage machinery, or just want a high-precision scanner that can handle everything from small parts to big assemblies, the Surmoon S1 is worth checking out. I'll leave a link in the description down below so you can learn more, and be sure to take advantage of our discount code JAMSY10 for 10% off of a Surmoon S1 if you decide to invest. The whole point of scanning the Venturi is to extract the geometry of the internal features that would be somewhat difficult to pick up accurately with more traditional measuring tools. We can import the scan data into Fusion 360, at which point we can create some reference geometry that can be used to get a cross-sectional view of the Venturi. Then we can use that cross-sectional view, as well as some real-world measurements to create a dimensioned sketch that closely matches the scanned data. This is what we will use later on to turn a new Venturi out of aluminum, assuming our repair of the cracked cast iron housing goes alright. You busy?
Busy as I ever am.
Can you clean this up for me? And then I guess either you need to silver solder it, or you need to teach me how to silver solder.
What makes you think I know how to silver solder?
Because I've seen you do it. So
Are you trying to protect this thing's ears? What's this all about?
Well, I don't want the bushing getting glass beaded.
So you put earplugs in it?
Yeah.
Cool. Does that look any better?
Yeah.
Clean enough that we can solder it?
Maybe. Cracks never get smaller. But you don't think it'd be necessary to drill the end of the crack, but we're going to do it just to keep the crack from drilling it.
With what this is, I think the reason that's cracked is because it probably had water in it, sometime froze and expanded it. I don't think that's going to happen again. No reason for the crack to continue, but just in case, let's drill a little hole kind of right at the end of that. Let me stick the Magnaflex on here and see if we can see just exactly where that goes to. Okay, there you go.
Yeah, it goes all the way down right to the...
Right to where it gets a little larger. But I'm glad we did that. I'd have drilled closer down there, but I'd have drilled a little bit more to my right-hand side here. I've got my silver solder here, silver flux and the solder itself, and we need to put some of this silver flux paste on there and then heat it up and let that hopefully work into the crack and clean the crack a little bit more. I wish we had some new flux. This is quite hard. I can't squeeze it out anymore. This stuff is completely dried up.
So why silver solder instead of weld or braze or...
Well, you probably could braze this. That would be an option. Cast iron does not weld well, so we're not gonna even attempt to weld it. I do think silver solder is probably our preferred method.
So you're just trying to get that flux to seep down into it?
Yeah, I was hoping that would go down, work its way down into the crack and clean that. gonna stop right there. Grind it off, sand it, make it pretty. We hope it's, we're after functional, not pretty.
Yeah.
I'm going to say it's fine. If we did this right, what's in between is what's holding it together, not what's on top.
Right. Did we do it right?
Well, of course.
In the last 25 years, how many times have you silver soldered?
Twice.
So. In the last 50 years, how many times?
Twice.
Actually?
This is something new to me. I've never done that before.
Well, you did it on a piece on the dyno, and it worked.
Yeah.
It's still working, surprisingly. Yeah. And that was a pretty small
piece with
quite a bit of load.
With pretty big load on it. Yeah, see if you can dress that up a little bit. You're pretty good at smoothing things over.
Trigger warning.
The housing looks pretty dang good at this point, and from what I've heard, they say that a grinder and paint makes me the silver solderer I ain't. So we gave it a coat of some cast iron gray to make it look like nobody had ever been there. Next up is to manufacture a new Venturi. We'll be turning the Venturi out of some 2.5 inch round aluminum, quite a bit larger diameter than what we really need, but it's what I had on hand. I'm not going to talk much throughout this part of the video, but keep an eye out for the text overlays explaining what's happening, and the screen recording of the Haas control is there for those who are interested.
You know what you're doing?
No.
Anything I need to do to help you, or
No.
stay out of your way?
No, I put the, for now, just stay on my way, I suppose.
Since I still haven't made time to learn how to use Fusion 360's cam, I simply copy the sketch over into the shape creator on the Haas control, and then use the conversational programming on the control to set up our ID stock removal programs. With the bottom half of the Venturi finished, I flipped the part in the chuck, which left about an inch of extra material. Rather than cutting it off with the bandsaw, I decided to let it be waste and turn it into chips here on the lathe.
.2072, so I need to subtract 72 off of my offset.
We let all of the hardware run in the ultrasonic cleaner for most of the day, hoping it would clean up some of the grime, while maybe still leaving a bit of the patina look. With the crack in the housing repaired and our new Venturi manufactured, we're ready to put the carb back together. Although I don't think it would matter at all if it wasn't sealed, I went ahead and used some Hylamar between the OD of the Venturi and the ID of the housing. I installed the throttle shaft with some assembly lubricant on the bushings, and we used the vise to press the outer brass retainer/seal piece back into place before pinning it with the cotter pin.
Now, is that thing, the edges of it tapered to where it has to go?
Yeah.
Enough? I would say probably just kind of snug that little at a time and keep working with it till it feels like it's in a good spot. What if you count how many turns it takes to back that screw off, and that way this would go close just a little bit further to maybe center it better?
Okay.
Providing that screw will turn.
Half. 1. Half. 2. Where does that get us? There. Half. 3. That was a pretty smart idea.
I do have one of those once in a while, in between my senior moments.
So now it kind of
Yeah, that's what I was hoping
locates.
is if it went closer to being all the way shut, it would locate itself a little bit better. You know, I was showing you there, I thought it looked like there was a little tiny peen mark. Mm-hmm. I'll bet it wasn't any more than they took their screwdriver like that right there and tapped it.
Yep. With that being an updraft, if that screw came out, it'd probably fall right down.
Probably, yeah, how hard would it be pulling air through there? Would it actually pull it up? There. Okay, I feel better now. So now adjust your throttle back where it was. I think that's interesting that they use a lock screw against the side of that. And on modern carburetors, I mean, I'm talking 1950, 1960, they would have a heavy spring on there to just keep tension against it.
Right.
It should seal just the way it is. That's where it pulls air in, isn't it?
Yeah.
Huh. Look at that. And I would screw that in till it bottoms out and then back it out a turn and a half.
That's what you did back
That's what we used to
when these were new.
back when they were new. It's kind of like you do the idle air mixture screws on a.
1.5.
Yep.
And then this little guy was in here, but they had to have a hole there to drill the hole through into the
Okay.
actual car.
That's good.
And I guess that's just a flange to change the mounting direction, or what's the point of that? Maybe on some engines it needs to be mounted this
yeah,
way,
maybe-
and on this one
maybe
it needs
so.
to- like I said, if it was
I would just go ahead and put that together. Because if you put it together, that little tube won't get bent. Maybe just leave them,
loose and tall.
yeah, until you kind of put it together so things wouldn't get bent, but he ought to take it apart and look at what you did, and that's a good idea. You had to go get a brass screw.
And with that, our work on the Zenith T5F for a 1920 Federal truck is complete. This was really my first opportunity to take on this type of a project, and it was a ton of fun using the modern technology of the 3D scanner, the CAD software, and the CNC lathe to breathe new life into a part that's over 100 years old. So I'm curious, what do you guys think a repair like this should really cost? In this instance, we're going to call it a freebie to the City of Greeley Museums and consider it my tuition for learning the process. Be sure to drop a comment, hit us with a like and subscribe, and stay tuned for the next one.